Welcome. So, welcome to Hindustan College of Engineering and Technology and Department of Aeronautical Engineering. So, this video lesson is all about wind tunnel techniques. So, what is wind tunnel technique is that? So, wind tunnel technique is a subject which helps the students to understand how in wind tunnel the measurements are being taken care of. In terms of how the model has been placed in the wind tunnel, in terms of how the model has been studied in the wind tunnel, to understand how the flow over the model is being there and how the pressure and velocity are measured in the wind tunnel. So there are many ways you can measure the pressure and velocity. So there are many equipments is there. So here we use pitot tube. So pitot tube is one of the important instrument to measure the pressure. So in pitot tube we usually measure two types of pressure. One is static pressure, another one is dynamic pressure. So in pitot tube, this is the way the pitot tube is there. In front of the pitot tube we will measure the dynamic pressure. On the pitot tube we will measure the static pressure. So by using this measuring of dynamic pressure and static pressure, we will be able to understand how and what way the pressure variation is happening in the surface of the model. So for upper surface and also for the lower surface of the model. So we using the reference of atmospheric pressure, we will be able to calculate the total pressure. So static pressure, dynamic pressure, total pressure. By measuring all these types of pressures, we will be able to understand how the post production is happening in the particular airfoil. So because the post production is happening, basically depends upon the pressure differences which happens in the airfoil. So pressure differences and pressure distribution around the airfoil is important parameter to calculate lift force, drag force and side force. So when the airfoil is having low pressure at the bottom, when the high pressure at the high pressure at the bottom, low pressure at the top means the airfoil will lift. So similarly, this is the way the model should behave. So we will be using lot of techniques as to understand how the pressure has been there and what are the ways to measure those pressures and all. So this is YouTube manometer. So what is YouTube manometer in the sense? The YouTube manometer helps us to convert pressure of the air to a water pressure. So the water pressure will rise. So based upon that, we will be able to calculate the pressure values. So here we will be calculating both static pressure and dynamic pressure also we will be able to calculate. So and also be using the reference values of atmospheric pressure. So this YouTube manometer consists of 13 verticals of levels of water. So similarly, we will have a 13 pressure tapping outputs will be there. So this 13 output pressure tappings will be connected to the airfoil. So this airfoils or any other models you can connect. So you can connect and take the pressure out of it. So how it works is that every tappings will be connected to the surface of the airfoil. So similarly, if you take the airfoil, so as upper surface of the airfoil will having six tappings and lower surface of the airfoil will be having the six pressure tappings. So 6 plus 6, 12 tappings will be there. Then 13 tapping will be the reference pressure that will be connected to the atmosphere. Based upon that, the reference water height will be adjusted. So this once the wind tunnel is started, once the velocity has been input has been given, the airflow will start flow over airfoil. Once the airfoil flow has been sorted, means the pressure differences will be seen in this YouTube manometer. In this YouTube manometer, water levels will be adjusted based upon how much amount of pressure should be created in the suction area and also in the regressive pressure tapping, regressive areas of the pressure. So in the based upon the water level, we will be able to calculate what is the height of the water level. So by using this height of the water level, we use hydrostatic equation, that is P is equal to rho g h. So rho is density, g is gravity, the h is height of the water. From that we will be able to calculate the pressure. So once we calculate the static pressure of the airfoil, we will calculate for different angle of attack also you can calculate. Similarly for 2 degree of angle of attack or 3 degree angle of attack, 4 degree of angle of attack, we can calculate. Or else you can keep the angle of attack as a constant and we can increase the velocity from 10 meter per second, 15 meter per second, 20 meter per second. We can increase the velocity to see that how the pressure variation is happening around the surface of the airfoil. So what is the objective of the study is that we will be able to understand how the airfoil is going to behave in a different flow, different conditions. Similarly, keeping an angle of attack as a constant, increasing the velocity, and similarly, likewise, keeping the velocity as a constant and increasing the angle of attack to see that how the pressure variations are happening in the around the airfoil. Similarly, you can test any of the automobile structures or any of the flow turbine blades also. You can test it in this particular test section with a velocity up to 30 meter per second. So this helps us to understand how the model is going to be behaving in a real-time environment. Thank you.